Greetings, class. I wanted to share a brief video with you that is designed to accompany a PowerPoint presentation that I converted to PDF file and posted in the folder for this week, the week of September 5th. The name of the file, and again it's a PDF, I posted it as a PDF file, is displaying data graphically. So if you don't have that file accessible, you might want to hit pause on this video or come back to it later and take a look at this video again when you have access to that file. But if you do have access to that file, I'm going to be referring to the slide numbers, which you can find in the lower right-hand corner of the slides themselves. So I just wanted to point out a couple of things, just an overview statement first. When it comes to displaying data graphically, what we're referring to, and what you might have seen in Chapter 2 of SPATS, is taking information, typically numeric information or other types of descriptive information, and creating a picture of some kind. And that picture could be a table, as in the case of a frequency table. It could be a pie chart, which many of us are probably familiar with. Or it could be a bar chart, or as you may have seen in SPATS, a histogram or a frequency polygon. Many years ago, when I used to teach this class, before a lot of software capabilities had been developed when it comes to the display of data, I used to spend more time than I do now talking about the display of data. But the truth of the matter is there's not much reason to do that anymore because there are so many software packages out there that are available online. Prezi is one that people that is freely accessible and usable and quite handy. PowerPoint, of course, is another way in which a lot of graphics are created when it comes to data, and one that I use quite a bit. But in reality, what I want you to glean, the main thing I want you to glean from Chapter 2 in SPATS, and the main thing I want you to be aware of when it comes to the display of data, the graphic display of data, is clarity. In other words, a good graph or a good table is clear and honest and portrays the information in an objective and fair manner, and also in a truthful manner. There's a book that you might want to look up. It's called How to Lie with Statistics. It's kind of a popular book, and it's one that many people who are very skeptical of statistics and statistical analyses point to say, look, you can make numbers, and you may have heard phrases like this. You can make numbers say anything you want. And to a certain extent, that's true. I have an appreciation for that sentiment, and certainly I will freely admit that when it comes to misrepresenting reality, using research, using data, using numbers, oftentimes it is in the graphical display in which those misrepresentations occur. So really, getting back to what I'm hoping you glean from Chapter 2 and also this brief video is an understanding of what some of the most common graphical displays of data are and how to interpret them and some things to know about them. So if you're following along on the PowerPoint, I'm really not going to show anything too interesting on this video. You can go ahead and minimize the video and just leave the audio going. But as you see on slide number 2, why do we use graphic displays? Well, as I mentioned earlier in my opening remarks, it's to tell the story of data, to tell the story, to communicate the most important items, the most critical items, the most truthful items about an analysis, without much effort, and that's really I really can't overemphasize that enough in the sense that a good graph, meaning a table, a pie chart, a histogram, a bar chart, a good graph tells the story to the reader, to the consumer, without a lot of effort. If you have to do a lot of reading and a lot of really fine-toothed combing, as it were, when it comes to a graphic, it's probably not a very good graphic. So slide number 3, some common uses of graphs and tables. Well, to offer a quick profile of a sample of cases of a group of data. In other words, again, I should be able to hold up a chart and see very quickly what the sample is comprised of, what their characteristics are, demographics, things of that nature. Displaying of trends is another common use of graphs and tables. And when it comes to producing research, that's why you're taking this class in part, is to learn about research and the importance of research and how research is generated. Graphics like tables and pictures and whatnot tend to break up the text and provide the foundation. Speaking for myself, when I generate research, I typically generate the tables and graphs first. So I have them all, typically in draft form, but I have them all laid out. And then I write. Then I start writing. I write the report, or I write the article, or I write the book chapter using those graphs. And so in other words, the graphs provide the foundation for what I'm doing, and then I write in order to support and explain and point out what's most important about those graphics. Again, slide number 4, important things to consider. Graphics should stand alone. They should not use a lot of text, and they should not be too crowded or busy. It's my hope that when all is said and done, if you've read chapter 2 and thought about some of the comments I'm sharing here, that you'll be able to recognize both a good graphic and a not so good graphic. Now, slide number 5. There are several common types of graphics that you need to be aware of. I've picked them out of Spatz. He mentions more than these, but these are ones that I want you to be most aware of. The frequency table, that's pretty much just a display of numbers. The frequency polygon, that displays the shape of a distribution of scores. Or numbers. A histogram, likewise. A histogram is very much like a bar chart, but a histogram also can show us the shape of a distribution. A bar graph is kind of like a histogram, but a bar graph deals with nominal level data and sometimes ordinal level data. And then a line graph, which can be used to display trends. So, looking at just a few of these examples real quick. I won't go over every single one that's in the PowerPoint presentation, but just wanted to point out a few of them. The frequency table, slide number 6. What you have here is a pretty easy to interpret frequency table. You've got a column called valid, which is the valid values, 6, 6.5, 7, 7.5, and so on. As we can see from the title of this frequency table, this is a frequency table of a sample of people regarding their shoe size. I know that's not very exciting, but it does illustrate a frequency table fairly cleanly. And then the next column is frequency. That's how many people or how many cases have that particular shoe size. So if you look at the column called frequency, you can see there's one person that has a shoe size of 6, there's 2 people that have a shoe size of 6.5, 6.5, there's 3 people that have a shoe size of 7, and so on, frequency. Then the next column is called percent. That's a really handy column because that shows us the percentage of the sample that is comprised of that particular value or that particular category. So for example, again, sticking with sizes 6, 6.5, and 7, we can see that 6.7% of the sample have a shoe size of 6. 13.3% of the sample have a shoe size of 6.5, and 20% of the sample have a shoe size of 7. The next column is called the valid percent. This column isn't very exciting because we don't have any of what's referred to as missing data. If we had some missing data, let's say these data came from a survey and it asked people, hey, what's your shoe size? And that turned out to be a really sensitive topic for somebody, maybe somebody who had really super duper small feet or somebody who had really monstrous feet and they don't want to admit what their actual size is, although shoe size should be pretty relatively apparent visually, we would have missing data. And in that case, we wouldn't know what one or more folks' shoe size was. So the valid percentage column would present the percentage of the sample that provided us with valid data for that particular shoe size. Now in this particular instance, as you can see, percent and valid percent are exactly the same, and the reason for that is there's no missing data. Then the last column is called cumulative percent, and that shows what percentage of the sample we've accounted for with each shoe size as it goes up. So, for example, the shoe size of 6, the cumulative percentage is 6.7. When we get to a shoe size of 6.5, we have accounted for 20% of the sample total. When we get to a shoe size of 7, we've accounted for 40% of the sample total. And then when you get to the end, shoe size of 10.5, we've accounted for 100% of the sample. Frequency table, fairly common graphic in a lot of empirical research. You've probably encountered frequency tables before. Maybe you encountered them and didn't call them frequency tables, or they weren't referred to as frequency tables. But that's what a frequency table is. All right, I will. In order to keep these the length of these videos manageable, I'm going to cut this one off and then upload a second one, which should probably be